last session, we have seen what is session affinity, what is sticky session, and what are the types and how to handle sessions. Um, yeah, and with session affinity, what happens, and without session affinity, what happens? We have seen all these things. So, uh, concluding on session management, it is very important to enable session management either with the cookie based or URL rewriting or session persistence with database or file system. And there is one more concept that is called coherence. So uh, in the initial classes when we were installing uh, WebLogic, we have seen coherence, which can be installed separately or which can be installed alongside with the WebLogic. So what exactly is coherence? So how it works and how it contributes uh, in performance of an application server or application. Let us see that. So Oracle coherence is an in-memory data grid. So it is a data grid that enables scalable, fault-tolerant, distributed caching and data processing across clustered WebLogic servers or standalone nodes. So what exactly it means? It is a data grid that separately, it stores the data, your application processed data on the server across clustered uh, WebLogic servers or standalone nodes. So in WebLogic, coherence is tightly integrated, allowing applications to use distributed caching natively. So what are the key uses? The first thing is session replication. It stores the HTTP sessions in memory across cluster nodes instead of database or file. And data caching. Cache frequently accessed database queries results in memory, reducing the database load. So, it is what it does is we know what is a cache, which stores the data on a system for fast and easy access without connecting to the external services. Uh, for example, your browser stores the cache, right? Whenever you type something, it automatically retrieves from the cache first. If you are commonly using the same website again and again, if you are accessing a new website, at that time it will connect to the DNS across internet, and it will get connected with the server and gets the response. But usually the frequently accessed data will be stored in the browser cache, right? So that is an example. And here in WebLogic, coherence, it stores the data, the frequently accessed database queries or frequently accessed application resources and sessions, everything will be stored in memory. So stateful application sharing. So it shares state or application data across nodes without DB hits. So here it is storing the database queries uh, frequently queried SQL statements will be stored. And event-driven architectures react to data changes across the grid in near real time. So totally synchronized. high throughput microservices use coherence as a fast and shared state store. So overall, what it does is it improves the performance by reducing the overheads on database and servers, system resources of your application servers. So what happens, all the frequently accessed data of your application and the sessions and database queries, everything will be stored in the data grid, which is coherence. Now, let us understand how it works. So you have created a cluster and you have added your cluster coherence. Let us say we have a cluster with two nodes. On two nodes, two machines, two servers are created. So your application, it stores all the servlets or requests, put, get, or we have discussed all these things. All these data, application data, to the WebLogic cluster. And your WebLogic cluster is tightly coupled with coherence grid. So the coherence grid, what it does is it divides the cache into two parts. It stores one part, which is primary on node 1, and the second part on node 2. Partition A on node 1 and partition B on node 2. And partition B's backup on node 1 and partition A's backup on node 2. Right? So first, it divides the cache into two partitions. The first partition, which is partition A, it is primary on node 1 and backup on node 2. In the same way, the second partition of your coherence cache, which is primary on node 2, the second partition is part B. So it will be backup on node 1, right? So this is what here I have created this diagram to understand. So it stores the primary backup A on node 2 and primary backup of partition B on node 1. So if the node 1 fails, coherence node 2 already has its own primary partition B and backup of partition A. So there will be no fault tolerance. Your WebLogic cluster will take over partition A from the backup, right? So let us break down, understand it clearly. Step by step. So how it works. So node 1, node 2. There is a cluster member and here is a cluster member. So there is a small service created on both the nodes, which is coherence instance, and here also coherence instance with storage enabled in memory, right? So each node runs on its own JVM, WebLogic or Jboss or standalone, whatever it is. It has a coherence instance that is storage enabled, meaning it can hold and manage cache data. So it communicates with other node to form a cluster and shared data. So when coherence instance with storage enabled is created, then these two instances, they communicate with each other to form a cluster and share data. which is cache. So how does nodes find each other from a cluster? So using multicast, already we have created a cluster, right? So either we'll use multicast or default, which is unicast. So all members broadcast on its own on a known IP and port. If another node is listening, it joins the cluster. And here static IPs and ports are configured. So each node knows how to contact the others. So what is the result? The two JVMs recognize each other from a coherence cluster, enabling distributed data operations. So this is how they communicate and discover each other. And data partitioning is also called as sharding. So what does partitioning mean in coherence? So like we have discussed, it divides the cache into two parts. So coherence breaks up entire cache into fixed partitions. By default, it is 257. These partitions are spread evenly across the cluster nodes. We have two nodes, node 1 and node 2. So node 1 stores partitions from 1 to 128 and node 2 stores the partitions from 129 to 257. So if there are more number of nodes, the 257 will be divided by 4. So each partition holds a slice of your cache data. Like, for example, there is a request, customer 123, partition 15, it is getting stored on node 1. And its own data, which is order 789 or something, it is getting stored on partition 200 on node 2. So what is the benefit? Load is balanced. Both nodes store part of cache instead of duplicating the entire thing. So they are not storing, they are not duplicating the entire partition. They are dividing. So on node 1, this will be primary and it stores the same customer 123 as backup. And order 789 is primary and it will store the backup of order 789 in node 1. Data replication. So this is how it stores the partitions. Data replication. So what does it mean? Backup partitions. How is data protected from a node failure? So each partition has a backup copy on the other node. Due to backup, count is equal to 1. So partition 1 is primary on node 1 and backup on node 2. And partition 130 is primary on node 2 and backup on node 1. So what it results in? Each node has its own data plus backup of other nodes' data. If one node fails, the data is not lost because it has its own data and backup of node 2. Partition 1 and partition 2. Partition 1 primary and partition 2 backup on each node. So how does an application use the cache? So let us say we have a Java application that does that executes this code. So what does coherence do? Coherence will hash the key to find its partition. Example, partition 15. It determines which node owns that partition. Example, let us say on node 1. So it will store the string in memory on node 1 and also write backup on node 2. So this is a key to find its partition, and it will be hashed. This string will be put into node 1 and backup on node 2. So similarly, for customer 123, the call is routed to node 1. So it results in efficient partition-aware data routing. Right? So data is stored and retrieved from the correct node, and it is transparent to the developer. The API looks normal map. So this is an entire internal workflow. So what usually we do, we create a cluster and we will pin it to the coherence, and it will create a grid, and on both the nodes, it will create the coherence instance that will communicate with each other and divide the entire cache into two parts evenly. And one node will have a primary backup, not backup. One node will have a primary partition, and on the other node, it stores the backup. In the same way, vice versa. So failover and node balancing, rebalancing or load balancing. So if you take a scenario like node 1 fails, all partitions it owned are now missing, but node 2 has backups of those partitions. Coherence promotes the backups on node 2 to primary partitions. So what it does, it will promote all the partitions to node 2 as primary only when node 1 fails. And applications continue to access cache without errors. Now cache is still available, no data loss. So this is fault tolerance. And what happens when node 1 rejoins? Coherence rebalances the partition. It moves half of the ownership back to the node 1. It copies back necessary data to rebalance, right? So this is very efficient, and it results in cluster restores optimal load distribution. So once the node rejoins, it is not continuing like both the partitions as primary. It is moving half of the ownership back to the node 1. So this is rebalancing and automatically handled in the background. You don't have to do anything. So in summary, cluster formation. Nodes discover each other via whatever the messaging mode is configured. Partitioning. Data is divided across nodes for load balancing. Backup and replication. Backups are kept on the opposite node for fault tolerance. API operations. All these put get methods get routed to the correct node. Transparent caching. Failover and rebalance. Backups promoted on failure, rebalanced on recovery. So distributed cache, Coherence stores session data in a distributed in-memory data grid. Better scalability works better in large clusters with many servers, and reduced WebLogic memory usage. It offloads session storage from WebLogic memory to Coherence. And improved failover. It provides a more resilient and efficient failover mechanism. So how do you configure this one? It is configured on the WebLogic.xml, which is WebLogic specific deployment descriptor. So session replication is configured with Coherence Web in persistent store type. So in the last session, we have seen persistent storage like JDBC, clustered, or file. So these are the different flags that can be used in the deployment descriptor. So if you're using Coherence, then you will give Coherence Web in the deployment descriptor. So it enables WebLogic Oracle Coherence Web for distributed session management.